Welcome to HMS, let the power flow. Feel the rhythm in your veins. Every rapid nitro flame.
Caffeine. Love caffeine. Who doesn't love caffeine? Okay, anyway. Caffeine is a naturally occurring substance that acts on the central nervous system, CNS, to reduce perceptions of fatigue. Okay, so it doesn't actually make you less tired. It makes you think you're less tired. So therefore you keep doing things for longer and then you pay the consequence later. It is a group A supplement. So the AIS recognizes that there is strong scientific evidence to suggest that caffeine is very beneficial. Why would you take caffeine? Okay, so it does reduce perceived fatigue, allowing optimal pacing for longer. Okay, so if you are running and you're starting to get fatigued, so if you're a marathon runner getting fatigued, you have some caffeine, you can keep maintaining that pace and run for longer. Okay, even though your body is actually tired, your brain is now like, no, we're not tired, let's keep going. All right. It's also why people take it in the morning. They wake up first thing in the morning and they're tired, they take caffeine and they feel less tired. So they're actually not less tired, but they feel less tired, so then they do stuff. Caffeine helps mobilize fats to create or resynthesize ATP. So remember, in the aerobic system, you can use fats to resynthesize ATP. So taking caffeine actually assists that process. So that's good. It does increase your reaction time and increases arousal. So if you are under aroused for an event or if you need to react fast in an event, then having some caffeine may help with that response. It is beneficial for both endurance type athletes because of this perceived fatigue and power type sports because of the arousal, etc. And caffeine is also, caffeine can also be beneficial if it's taken pre-event to get you ready for the event, and you can have caffeine during your event. So a lot of those like glucogel things that like triathletes and marathon runners use have a small amounts of caffeine in them. Now, what's bad about caffeine? Okay, so first of all, I touched on this in the other video. It can disrupt your sleep if it's taken too late. And if you don't sleep well, then you're not going to recover well, and therefore your performance is going to be significantly lowered, all right? Caffeine can actually cause over-arousal and therefore anxiety, and it could make you jittery. So if you're like a darts thrower, for example, and you have too much caffeine and you're trying to like precisely throw the dart, but you're like this because you've had way too much caffeine and you're all jittery and over-aroused, well, your performance is going to be significantly bad. It can increase your blood pressure, which leads you to a feeling of like tense and stress. So if you've had too much caffeine, you might feel a bit pent up, and that's distracting if you're trying to focus on doing a certain movement or a certain skill. And caffeine is a diuretic. So diuretic meaning that it makes your body lose fluid. Okay, so therefore it can actually cause dehydration, and therefore we've learned that like 2% loss of hydration in the body leads to a 10% loss in performance. So therefore your performance goes down dramatically. All right, so for and against, and it comes down to taking the right amount of caffeine at the right time in the right quantity for the athlete. We got one more. Okay, our last one is creatine. All right, so creatine is a compound found in skeletal tissue. In other words, you're going to find it in meat. So it's in human skeletal tissue, but it's also in animals, and it's very high in cows. So creatine is used to regenerate ATP during short, intense bouts of efforts. Okay, so do you remember when we learned about the ATP-PC system? Okay, so remember your muscles have like the ATP-PC system, and they've got these molecules of phosphocreatine in them, and they do something really extreme like a jump or a sprint or a couple of reps or some reps in weightlifting, etc. And then you need to rest, and as you rest, those phosphocreatine stores join back on to create more ATP-PC. So consuming creatine just increases the amount of things here in the ATP-PC stores in your body. So it doesn't actually extend the amount of effort that you can do the hard thing for, but what it does is it increases the amount of times you can do the hard thing for in a period, all right? It is a group A supplement as well, so very widely, highly researched and strong evidence. So as I was just saying, it does enhance your PC stores, leading to more repeat efforts. So for example, the easiest way to think about it, if you were going to do an all-out squat workout and you were doing 5 sets of 5 reps, which is a very 5x5 program for strength development. And usually at the end of 5 sets of 5 reps, you are dog tired and you can't do another rep, okay, even after resting for 3 minutes. If you supplemented creatine for like a month, and that's on 5 grams a day, you might be able to get a 6th set now. I'm not saying you'll be able to get 5 reps, but you might be able to have just enough recovery there to get 1 extra set, okay? Or imagine if you're doing like sprint training and in a typical sprint session, you're only able to do 8 100-meter sprints and then you are done. Well, after supplementing with creatine for a while, generally it takes a month, you might be able to do 9 sprints and then you're done, okay? So it doesn't make the sprint longer and it doesn't make you faster, but, well, indirectly it might, but it does increase the amount that you may be able to resynthesize and therefore do a little bit more effort. So creatine increases cell size due to water retention. So what it does is that when you put more creatine molecules in your muscles, it's got to go in there somewhere. It doesn't just go in like a dry powder. Like you're not going to cut open a muscle and see dry powder in there. What you are going to see is obviously blood, which is fluid. So hence, when creatine gets stored into your muscles around your body, it takes fluid with it, okay? This increases the cell size, and this is why some clever marketing strategies is that like creatine builds muscle, because if you scanned a body that hadn't had any creatine and then you did a tissue scan of that same body after 30 days of creatine, it would actually look on the scan like their muscles are bigger. Because their muscles are bigger because there's more water in the muscles. It's not actual muscle tissue, okay? And creatine has been researched to be completely safe, providing you are maintaining adequate hydration. I will say that safe in adults, all right? They generally don't do studies on children, so they can't really recommend that children take creatine. Now, why wouldn't you take creatine? Well, if you take creatine and it forces more water into your muscles, while that's a good thing if you're a strength and power athlete, it's a bad thing if you're like a weight class athlete, because if you weren't taking creatine at all, okay, and you weighed like 70 kilos, and then you started taking creatine and you needed to make weight for boxing in the 70 kilo class, all of a sudden after a month you are up at 71 kilos or 71.5 kilos because of all the extra water your body's holding. Well, guess what? You can't compete anymore, all right? Also important if you're like an endurance athlete, like a marathon runner, because they don't want to be carrying excess weight because they've got to travel 40 kilometers, all right? Creatine also has smaller benefit, less, that's a better word, less benefit for high meat eaters. Because creatine is present in, steak, chicken, fish, etc. If you're eating enough meat per day, you're probably already getting your 5 grams in your diet, hence why it's called a supplement, okay? But in saying that, actually, and that's probably a benefit that I didn't write up, while there's little benefit for meat eaters, there is high benefit for, that's right, the vegetarians or vegans. So if you're a vegetarian or a vegan athlete, you should absolutely take creatine. I mean, I'm not telling you what to do, but anyway. So creatine, despite, I explained this already, despite the marketing hype and despite what the supplement guy at the store will tell you and the back of the bottle says, it does not build muscle, okay? What it does is it increases cell size and increases ATP PC stores, which could lead you to train a little bit harder. And training a little bit harder, according to the principle of progressive overload, will build muscle. But taking creatine itself does not build muscle. And if you are not adequately hydrated or taking enough water, and usually with creatine you want to take some sort of carbohydrate solution as well, because that will also go into your cells, so it's like a triple whammy. It can actually pull water from your body, and if it's pulling water into your muscles, it's got to pull it from somewhere, and generally it comes from like your extremities, like your head, and you get massive headaches with creatine, so that can be bad too. Right. I don't know if my editing magic can get this under 20 minutes or if I'm going to have to split it, but that is or was the video on supplementation for performance. Thanks.